In this video, you will learn how to create a machine learning model and how to deploy it using Flask from scratch. Watch the video till the end so that you will understand everything step by step. We are going to do two steps. The first step will be building the ML model, that is the machine learning model. Then the second step will be to deploy it using Flask. And in the process of building and deploying, we will create several files. And the first file will be model.py. This is going to be a Python file, and this file will contain our machine learning model. Once we create our model, we will convert this model into a Pickle object. Then we will make one Pickle file, that is the Pickle of our machine learning model. Then we will create one more Python file, app.py, and this file will contain our Flask application. Then we will also have one more file, index.html, and index.html will contain the HTML codes which we will see on our server. Then we have one more file, this is the iris.csv. This is going to be the data. We are going to use this data to develop our machine learning model. We will use PyCharm IDE to develop our ML model and deploy using Flask. You can use any other IDE of your choice such as Visual Studio Code or Spider. First, I'll create a folder in my C drive. I'll click on this PC. I'll go to C drive and I'll make one folder here. And the folder name will be ML model deployment. And inside this folder, I will put two files. The first will be the data file, and the data file is on my desktop. So I have iris.csv. I'll copy this from here, and now I'll go to the folder and paste it here. So this is going to be the data file on which we are going to develop our machine learning model. The second is the template folder. So I have this template folder. I'll copy this and paste it in my folder here. I'll give you all this file. I'll put the link of my GitHub. From there you can download this code. So in our folder templates, we have a HTML file, and this you can see that we have this HTML file. I'll show you the code inside this. I'll right click on this and then I will open this with Notepad. And you can see that these are the HTML codes. So we have given our sepal length, sepal width, petal length, petal width. So these are our independent variables in which we will put the values and then we will get the output. So you don't have to worry about this HTML file. I'll share this with you. You just have to copy, paste, and then put it in a folder like this. So you have to make one folder where you will have this template folder, and inside this HTML file, then you have one data file. Now I'm going to open the PyCharm and I will tell you step by step what we have to do. So I'll type PyCharm here. Now I'll click on open. Then I'll go to the C drive. So first I'll click on this refresh button. Now I'll open this C folder. Now here we have made one folder, ML model deployment. You can see here I have made this folder right now, ML model deployment. So I'll click on this and click on open. So we have opened our folder in PyCharm, and you can see here we have iris.csv and the folder templates already here. To create a Python file, you have to click on this folder name, then right click, then choose new, and from here you have to click on the Python file. Then you have to give the name, and our first file name will be model.py. So this is our model.py file, and in this file we will create our machine learning model. Let's import all the libraries that are needed to develop our machine learning model. First I will import pandas spd to read our CSV file. Import pandas spd. Then from scikit-learn dot preprocessing import standard scaler. We will scale our data independent variables. From scikit-learn dot ensemble import random forest classifier. We are going to apply this random forest classifier on our iris dataset from scikit-learn dot model selection import train test split, and this will be used to train and split our dataset into train test. Now we are going to load the CSV file. I'm going to explain you each and everything step by step, so you will understand everything and you will be very confident after watching this video. I'll make one variable df, and now from pandas I will call the method read underscore csv, and inside this I will pass our CSV file name in double quotes, and our CSV file name is iris.csv. You can see here, so I'll write iris.csv. Now we will look at the top 5 rows of a data frame df, so I'll write df.head. Using head function we can look at the top 5 rows of a data frame. So now I'll right click here and then I will choose run model, because our file name is model, you can see here, so I will click run model. It has been run successfully, and here you can see that process finished with exit code 0, but we did not see the head because we have to use the method print here. So I'll just type print and then I will cut this code from here and put it inside this, and now I will run this again. So I'll right click and click on run model. In the output you can see that we got the top 5 rows. So these are the head. We have columns such as sepal length, sepal width, petal width, and class. Class is a target variable, while sepal length, sepal width, petal length, and petal width are independent variables. We are going to use these independent variables to predict our class, whether it belongs to Setosa or any other class. We will separate our independent and dependent variables. In X we will have all the independent variables, and in Y we will have all the dependent variables. Select independent and dependent variable. So in X we will have all the independent variables. So now here I will call our variable df, and then I will make a list inside a list, and then I will pass all the independent variable names here. So first is going to be sepal length, second sepal width, third petal length, and fourth petal width. These are our independent variables. Now I will make one variable y, and in this we will have our dependent variable, and our dependent variable or the target variable is the class variable. So I'll call our data frame df, and then I will type the variable name class. So we have got x and y. Now we are going to split the dataset into train test. Split the dataset into train and test. I'll make variables xtrain, xtest, ytrain, and ytest. So first is going to be xtrain, then xtest, then we have ytrain and ytest. Now I will call this method train test split. So train test split. Now inside this we have to pass our independent and dependent variables. So we will pass our variable x and y. X contains our independent variables and y contain our dependent variable. Then we have to pass some parameter. The first parameter is going to be test size. That is, we are going to build the model on 70% of the data, and the remaining 30% of data will be used for testing. So here I will type 0.3. That means I am saying that 30% of the data will be used for testing. Then there is one more parameter, random state, and here you can give any number. Here I'll put 50. If you want your result to be same as mine, then you also have to put 50 here. Next we will do feature scaling. I will call this class standard scaler to standardize our independent variable. I'll make one variable sc and I will call our class standard scaler. Sc will be an object of this class. Now I'm going to apply this standard scaler on xtrain and xtest. First I will call this variable xtrain. Then I will call object sc, and from this I will call the method fit and transform. Then I will pass our variable xtrain. We will do the similar process on xtest. So I'll call xtest. Then I'll call the object sc. Then we have transform. And I will do this on xtest. So in xtrain we are doing the fit as well as the transform, and in xtest we are only applying the transform method. Here we have done the feature scaling. The next step is to instantiate the model, and we are going to use random forest classifier to develop our classification model, to develop our machine learning model. So first I will instantiate the model. I'll make one object classifier. Like we have done here, we have made the object of the class standard scaler, and here we are making an object of our class random forest classifier. Now I will call the class random forest classifier. So this object classifier will contain our class random forest classifier. Now we are going to fit the model. So we will call this object classifier, and from this we will call the method fit, and here we have to pass our xtrain and ytrain. So we will pass xtrain and ytrain. So here we are doing the fit on the model. We are applying this fit method, and once this fit method is done, that means we have built our machine learning model, and the next step is to make the pickle object of our model. So here you can see now we have two files, model.py and iris.csv, and now we are going to create one more file, that is the pickle of our model object. So let's make pickle file of our model, and for this first we will need to import the pickle library. So here I will call import pickle. Now I will call this pickle, and I will use the method dump. Inside this we will have to pass our object, this classifier. So we will write classifier. So whatever you use for fitting your model, here we are using this classifier, random forest classifier, to fit the model. So in pickle dump you have to use that same classifier here. So that's why I'm writing classifier here, because we have used this to fit our model. That's why in pickle.dump I am using this classifier, because we are going to dump this classifier. Then we have to pass parameter open, and then we have to give our model name. So we will give our model as model, and then the name will be model, and then we have to type the extension. Since this is going to be a pickle file, so we will write .pkl. This is the extension of pickle file, and then we have one more parameter, wb. We have called pickle class, and from this we have used the method dump, And then we have dumped our model classifier, which we have used here to fit our model. And then we have given the name to our model, and the extension is model.pkl. Pkl because this is a pickle file, so we are using the pickle extension here. Now I will run this code, and after running this code, you will see here we will get a new file, and that file will be model.pkl. So I'll run this code. You can see that we got a new file model.pkl. We have successfully converted our model into a pickle file, and we can also verify this from our folder. I'll open my folder here, and in the folder you can see that we got this pickle file model.pkl. Let's verify what files we have created. We have created model.py. We have also created model.pkl. We already have index.html. We already have iris.csv. The only file left is app.py. This is the Flask application, and this is the last one. Now we are going to work on this Flask application. We will create our last Python file, that is the app file, which will contain our Flask code. I'll click on this folder, ML model deployment, right click, new Python file, and the file name will be app.py. Now this file will contain our Flask code. Let's import all the libraries. Import numpy as np, from Flask import Flask request JSONify render template. When you use the Flask environment, you will get this message here in PyCharm. You are using the Flask framework, and we are going to make use of all the class here, Flask request JSONify render template. Now first we will create the Flask app. To create a Flask app, you just have to give one app name. So I'll give the variable as app, and now from Flask we will call this underscore name. That's it. Now you have created an app. You just have to give any name here. I am giving a name app here. Now we are going to load the model, this pickle model. We have to load this model here because we will make use of this model to make predictions. So first we will load this model. Load the pickle model. I'll make one variable model. Now we will load this model. We also need to import pickle. So I'll import pickle here. Now I will call pickle dot load. We will use the method load from our class pickle, and then inside this we will pass our method open, and inside this we have to pass the model name, and our model name is model.pkl. So we have to write this here in double quotes, model.pkl, and then we have one more parameter rb to read our file. So here in this line we are reading our we are loading our model and saving it in the variable model. So whenever we want to make prediction, we will use this variable model. Next we will define the home page, and we will use our app to define the home page. So I'll first call at the rate, and then I will call this app. From this I will use the method route, and inside this in double quotes I will put one slash here. This means this app will take me to the home page, and then I will define a function, define home. So I'm defining a function for home page, and this, once it takes me to the home page, it will call this function home, and this home function will return me render template, and inside this I will pass our HTML file which we have in this folder template. We will define one more method, and that method is going to be predict method. First I will call this @app.route, and this time this will take me to the page where the predict method is defined. So I will write here // and this time I will write the method name predict. So when I will call this will take me to this predict method page, and the method is going to be post. In Flask, we have two types of method, the get and post method, and here we are using the post method because we are going to receive the independent variable values. So that's why we are using post here. And now we will define our predict method, define predict. So when our app will go to this page predict, this predict method will be called, and first I'll make one variable float underscore features. So I'm making this variable float features because you can see here that our independent variables had got float values. That is, the values are in decimals 5.1, 3.0, 1.3. The values are decimals. That's why I'm making a variable float features where I'm going to convert all the numbers into the float variables. So I'll make a list comprehension and I will call a loop here, for loop float of x for x in request dot form dot values. Here I am saying that when I am going to receive the request, that is the independent variables values, that is these values, when I will receive these values, I am going to take those values and convert those values in float and then save those values in the variable float features. So someone will send us these independent variable values. These values will be sent and they will send in integer. So we are going to convert that integer into float and then save it in the variable float features. And the next step will be features. I'll make one variable features. And now I will make one more list comprehension. And now here I am going to convert this float into arrays. So I will call from numpy dot array, and then I will pass our variable float features which we have saved above here. So I'll pass this variable here, float features. So here in this step I am just converting this float features into numpy arrays. Now the next I will make one variable prediction. Now I'm going to make the prediction, and to make prediction we have to call our model, and our model is saved in this variable model. So we will call our variable model, and from this we will have to use the method predict, because to make prediction we have to use the method predict. So we are calling the method predict here, and inside this we will pass our variable features here, because features contain the values of our independent variables. So these are independent variables and this feature will contain these values, for example 4.9, 3.0, 1.4, 0.2. So whenever we pass any number here, those number first will be converted into float, and then those float will be converted into numpy array and stored in this variable features. And then using this feature we will make the prediction and save in the variable prediction here. Now once the prediction is done, we will use the method return, and return will call us render template, this class random template, and this will take us to the index HTML, index.html page, and there we will show our values. So we will use prediction underscore text. This is a parameter, and here we can type anything. For example, because this model is related to iris flower, so I will write the flower species is, then dot format, then I will call prediction. What I am doing here is, once I get the prediction, it will take me to this page index.html, and then it will print this text as the heading the flower species is, and then the species name. So whatever species we will get in the prediction, that species name will be printed, and along with that this statement will be printed. We can put any statement here. I have to remove this L from here and I have to put L here. Everything is completed. We just have to write one more line, and this is going to be if name is equal to main, then we will call our app dot run, and debug is equal to true. That's it. We have completed our Flask app. Now I'll right click here and then click on app. I got type error. In it got an unexpected keyword argument method. Here instead of method I have to type methods. I have to put s here. I'll put s here, and now I will run this code again. Right click on run app, and now let's see. So now our app has started and it is running on this port. So you can see here we have some numbers here. http:127.0.1 is to 5000. So this is the port on which our app is running, and this is the default port on Flask. Now we have to click on this port. So I'll click on this HTTP and this will open me in a new browser. I'll click on this. Now here we can see that we got the app here, flower class prediction. If I go back here, you can see we have successfully run our app and it is running on this port. Now we just have to put the independent variable numbers here, and this will predict class for us. For example, I put for 1.2, 5.1, 4.8 and 0.1, and if I click on this predict, this will predict the class of our flower iris. I'll click on this method predict. In the output you can see that it is saying that the flower species is Virginica, and this statement the flower species is which we have defined here. You can see here in prediction text I have defined that the flower species is, so that is why here we are getting the flower species is, and then we got the prediction here. Whatever prediction we are getting here, we are calling this along with this statement. Now if I put some different number, let's say I will put 0 0 0 0 0 0. Now here you can see that we got the flower species is Virginica. If I click on this method predict, now we got the flower species is versicolor. So we have successfully made the Flask app and we have deployed our machine learning model. So here you can see that these are the steps. First, we have to develop a machine learning model. Then we have to convert that file into a Pickle object. Once we convert that into a Pickle object, we have to make one Flask app. And once we make a Flask app, in Flask app, we have to load that model, that Pickle object. Then we have to define the predict method. And then using that predict method, we can make the prediction. I'm sure after watching the complete tutorial now you are comfortable on developing and deploying your model. If you face any problem, you can write down in the comment section and I will try to help you. I hope you enjoyed this video. If you like my video, please subscribe to my channel. Thank you for watching.